Okay, we're going to revisit this stop and auto restart after a specific time period project again. When I was researching how to do this with an Arduino, someone mentioned 555 chip. So I never even heard of that before. And so I did research, if you want to call it that, on YouTube. But there's actually a lot of good information on YouTube about the 555 chip. And so it works really well as long as you have a motor without a brake. So this motor here doesn't have a brake, so the magnet goes past the reed switch and it clears it, so the reed switch is not closed all the time like you have a motor with a brake. So here's a motor with a brake, so it's going to stop almost immediately once the reed switch is closed and the circuit does what it's supposed to do. Disregard that relay you see in the bottom there. I was experimenting with something and that's not actually doing anything. But you can see here, once that reed switch is closed all the time, it won't restart. This is a close-up of the dot, and we'll go through this diagram next. So the dot tells you where number 1 is. And so then it goes around this way, 1, 2, 3, 4, 5, 6, 7, 8. So when you're looking at a diagram, you know where to connect things. So number 1 is ground, so it's going to go to negative rail if you're using a breadboard. And as you can see, as we did earlier, negative rail. Then the trigger gets a 10K to positive. So that holds that positive until the trigger sends a ground to that, overriding the 10K resistor. So when that sees ground, that's when things start happening over here. Three is the output. So when this is triggered, this is what's going to trigger. In our case, we used a relay or an LED if you're making a test board. The reset just goes right to positive. So there's our pull up. That goes to positive. This is the output. This, and I've seen videos where they don't use this capacitor here. So I put it in. I had to order that special. It didn't come in my kit, the one I needed. So I had to order this one special, that 103. Then we have our capacitor here. This is the one that we change to change the speed of the timing. This and this resistor. So we started with the 100K here from positive to 7, plus these two are jumped together. As you can see that little jumper. So you can change these to change the speed of this. So the capacitor, the resistor. Make sure you hook the resistor to positive. A few times I accidentally connected it to the ground rail, and then nothing will happen here. It'll just stay activated the whole time. And then this one here is just positive. So number 8 just gets your positive. So here we're going to actually wire one up. I've got one there for an example. I'm going to start with 1, which goes to ground. So you see it's in the ground row. Here I'm going to trim a resistor so it fits a little better and looks a little better. So it's a 10K resistor there on pin 2. It's my first time playing with the 555 chip, so I found them pretty fascinating actually. I really enjoyed doing this project. So pin 4 goes to the positive rail. It's called the reset. And that's what I'm using to trigger the relay when we get into the relay later. So on 8, we're going to connect that to the positive voltage. And I'm using 12 volts because those motors are 12 volts. So I just used 12 volts on the whole project. I don't remember off the top of my head what the rating is of the chip, but it does handle 12 volts. So that resistor is 100K. So we're starting with 100K. Then you put the jumper across 6 and 7. So we'll play around with the resistors later on. And there's a capacitor. You can change those. So the resistor kind of slows down the capacitor getting charged, and when the capacitor reaches a certain charge level, that's when it activates the chip. And that's the capacitor to control the voltage, keep it stable. Then I put a couple jumpers across the board, so each side had power. And now I'm just putting in a little switch. You can see some jumpers. One's going from ground to one side of the switch, and then on the other side, or the button I should say, and then it goes to the trigger. So when it's just sitting there, it's just seeing a little bit of voltage through that resistor, and when you push the button, it goes to ground. So here I'm going to pull that resistor and we're going to measure it. The ohm meter, you can see it's a 100K resistor. So you can make your own resistors by parallel or series. This is in series. So I got 100K and then 100K on the other side, which gives you 200K. So if we pop that 200K in there, you can see that was a small capacitor. So we put a little bit bigger capacitor, I think a 47, and it lasts about 12.5 seconds. This is with a 100K, and it's about 6.5 seconds. So you can see about half. This was a 10K, and you can see it's really fast. And then just for fun, I tied a 100K and a 10K in series. So 110K. It's not going to be much different than the 100K. I think the 100K was 6.5 seconds and the 110 was about 7 seconds. Okay, the wiring diagram is here's the positive junction. So positive's going to go, put it into the positive rail on the breadboard. Another positive is going to go to 30 on the relay. Then the center post of that relay, which is I think 87A, goes to the motor. Then the negative side of the motor just goes to the junction. And then you need a negative out of the junction to the negative side of the rail. I have it over here. That's why I have these jumpers. You can put it on either side. Then you need a negative, a ground going to the, I got it on 85 on this one, on the relay. So the relay has power on both sides of the coil when it needs it. And then the switch on this one gets triggered with a negative signal. So we have to have a negative or ground coming out of here, going to the switch, and then out of the switch to our trigger, which is number 2. And then the output here, I left the LED in just for fun. But then the output goes to this side of the relay. And that's a positive signal to that side of the relay. Here's just a close-up because you can see what I've done later. The white wire is going to where the switch side of the button is, but I'm going to put that to the reed switch. And then the blue wire is going to go out to the relay. So we're going to use that relay to control that motor. That motor draws just a little bit too much for this switch, so it needs a relay in between. So now we're going to actually wire up the rest of the circuit. I'm going to start with the ground side of the motor. I'll put that to the ground or negative junction. Then that is ground feeding the reed switch. So it's going into the reed switch. Then I'm putting ground on the breadboard. And then to the trigger, I'm putting the other side of the reed switch. So when the reed switch closes, it'll send the trigger. I left the button and the LED in that circuit. It's still all going to work fine. Now we're getting the ground to one side of the coil on the relay. This is positive to the breadboard. This is the output, so we're going to put that on the relay. Let's finish up the other part of the relay. So the motor goes to that middle pin. So the relay is closed when it's de-energized, so the motor will run. And then when it's energized, the motor stops running. I just moved that wire to make this a little cleaner. So now we're going to put the positive wire to the pin 30 on the relay. And now we can hook up the positive side to the relay. So here it is working. You'll see here, I'll do a close-up of how that magnet goes past the switch. So the switch just closes momentarily. That is actually far enough away that that switch is not still closed. So you'll see a motor with a brake, that magnet's much closer to that reed switch and it stays closed all the time. And you can see here that magnet is actually keeping that switch closed with this motor with a brake. So while I was working all of this, I was trying to find a way to make the 555 chip work with the motor that has the brake. And I discovered this other relay module. I don't know why I couldn't find it when I did the original video, but we're going to do a video on that one next, and it works really well. So thanks for watching. We'll see you next time.